this video we are going to discuss about the initial value theorem. If we have to particularly find out the values of different variables, like suppose in function un you have to find out the particular discrete value of u2, u3, u5, then what? How can you find out? You have to apply initial value theorem or final value theorem. So initial value theorem, how can you find it? Listen, it says that if z transform of un is uz, then the value of u naught is given by the limit z tends to infinity of uz. Okay, what does it mean? Let us see through a proof. If uz is equals to zun, and you very well know that z transform of un is given by this sigma n tends to 0 to infinity. This is the definition of z transform. So if you substitute the value of 0, 1, 2, 1 by 1, what you get? u0 z raised to power 0, that means 1. u1 z raised to power minus 1, u2 z raised to power minus 2, and so on. So if you substitute the value of limit at z tends to infinity, what will you get? Limit z tends to infinity will become, if you substitute z, 1 upon z, z as infinity, so 1 upon infinity becomes 0. 1 upon z square means 1 upon infinity square also becomes 0. So only you left with u naught. So in this way you find out the value of u naught. Now what about u1, u2, u3? So for additional initial values you can find out. Let us suppose if you just neglect the higher powers, if you substitute, if you have to find out the value of u1, what you can do? Just take it in minus, and in left hand side, and just z inverse as in denominator. 1 upon z inverse becomes z. So this is the formula, z of uz minus u naught. Similarly, if you have to find out the value of u2, you have to just simply get that away into denominator. Z 1 upon z inverse square means z square, uz minus u naught minus u1 z inverse. Okay, this is our initial value theorem. Let us see some examples over it so that you can easily understand it. If let us suppose uz is equals to this function, then find the value of u2. Firstly, you have to find out the value of u naught, u1, u2 individually. Then only you can proceed towards the last value. Okay, so what you can do, just focus that this term can be simplified as 1 upon z. Why? Because as we know that initial value theorem is valid for z tends to infinity. So if 1 upon z is there, so 1 upon infinity comes out to be 0. So it will become simple. So that's why I'm taking out z square as common from numerator and z raised to power 4 as in denominator. Z square is cancelled with z square, it will form. Now it's time to find out the u naught. The value of u naught is limit z tends to infinity uz. You have to just substitute the value of uz there. So just forget about these terms. 1 upon z square, z is infinity, so 1 upon infinity square comes out to be 0. Now it's time to find out the value of u1. u1 is given by this formula according to initial value theorem. So just put down the value. As you know, u naught is 0 from this, and z, uz is 1 upon z square from here, and z is cancelled with z, then 1 upon z is still left, so it will form 0 obviously. Now it's time to the required value u2. So how can you find out the value of u2? Just apply this formula. Now substitute the value. u naught and u1 we find earlier that they are 0. Now it's time to find out these two terms. Z square uz. Just substitute the value of uz from here. As you see, z square is cancelled with z square. What is left with this? If you now substitute the value of or put down the value of z as infinity, what will you get? 1 upon z, that means 1 upon infinity comes out 0. 1 upon z square, 1 upon infinity square comes out to be 0, and hence the same. So what you get is 2 by 1, that means 2. I hope you understand. In our next video, we will discuss about further z transform and their properties and their inverse. Okay, till then, don't forget to subscribe my channel. Thank you.